Question number 58 says that A be a given matrix which is 3 cross 3 matrix given as 1 2 2 2 1 2 2 2 1. Then we have to choose the following options. So let us start with the characteristic equation involving A. So determinant of A minus lambda is equal to 0. So we have 1 minus lambda 2 2 2 1 minus lambda 2 2 2 1 minus lambda. The determinant value will be 0. From here you will get lambda plus 1 into lambda plus 1 into lambda minus 5 equals 0. Replacing lambda by A in order to get a matrix polynomial. So we have A plus I into A plus I into A minus 5i equals to the null matrix. So students, what do we have here? We have a quadratic equation involving A, and we can easily see that if I keep away the first factor, I can easily obtain the second equation. Obviously, A is clearly not equal to minus I. That is very clear. Is equal to 0. I3 means identity matrix of order 3. So clearly option number A is correct. If option A is correct, option B is also correct. You can pre-multiply with A inverse in order to get the same answer. Obviously, determinant value of A is non-zero. You can see that very clearly. If determinant value of A is non-zero, A inverse is defined. If A inverse is defined, A square is also invertible, A cube is also invertible. Okay. So C is wrong, D is correct. Final answer, ABD. Let us move on to the next section, which contains match the column type problems. Okay students, so moving on to the next section, which contains question number 59 and 60 based on the match the column type pattern. Match the statements in column 1 with column 2. Column 1 has 4 options A, B, C, D. Column 2 has P, Q, R, S, T, 5 options. A option says that let there be mapping F from R to R and Fnx is equal to F1 of F of n minus 1x for all n greater than or equal to 2 where n belongs to natural. F1x is x, then the solutions of the equation f3x into f2x into f1x minus 25 f2x f1x plus 175 f1x is equal to 375. So students, we have f1x as x. For f2x, I have f1 of f1x, that is again fx. That is again f1x and that is again x. Similarly, f3x, again f1 of f2x. So f2x is x, f1x is x. So it is again x. So all the functions are x only. So we have directly x cube minus 25x square plus 175x minus 375 equals 0. From here we have the factors x minus 5 into x minus 5 into x minus 15 is equals to 0. So x is either equal to 5 or 15, whereas 5 is a repeated root. Okay. So we have Q and S. So A matches with QS from column 2. Okay. Let us move on to B. B part says that the domain of the function 10th root of 4 par x plus 8 raised to power 2 by 3 times x minus 2 minus 52 minus 2 raised to power 2 into x minus 1. So we have the inside expression of the 10th root obviously non-negative. So 4 par x plus 8 par 2 by 3 x minus 2 minus 52 minus 2 raised to power 2 into x minus 1 as greater than or equal to 0. So we have 4 raised to power x, 8 raised to power 1 by 3 is 2, 2 raised to power 2 is 4. So 4 raised to power x minus 2 minus 52 minus 2 square is 4, 4 raised to power x minus 1 greater than or equal to 0. So 4 par x minus 4 par x minus 1 plus 4 par x minus 2 minus 52 greater than or equal to 0. If I put 4 par x as t, so this is t minus t by 4 plus t by 16 minus 52 greater than or equal to 0. Solving this, you will get t greater than or equal to 64. So from t greater than or equal to 64, I can say that 4 par x greater than or equal to 64, which implies that x greater than or equal to 3, which means the domain is x belongs to 3 to infinity in the interval form. We have to find out the domain contains which of the following elements. So B option clearly matches with all the numbers which are greater than or equal to 3. So Q, R, S and T are the correct choices for B part. Let us move on to C. C part says that let fx is equal to 5 sin inverse of sin x plus 4 tan inverse of tan x minus sine of sin inverse x and the possible integral values which fx can take. Students, the first term 5 sin inverse sin x has x belongs to R as the domain. Second one 4 tan inverse tan x, x belongs to R. Third one, the domain is minus 1 to 1. So if x belongs to minus 1 to 1, we can clearly say that the first term is 5x, the second term is 4x, and the last term is x simply. So we have 8x as the final answer, where the domain is x belongs to minus 1 to 1. So the range of fx is minus 8 to 8, because the function is directly 8x. So 1, 5 are the options which are correct. C matches with PQ. Okay, let us move on to D1. Question number D says that let A denote the positive root of the equation cos inverse cos x plus sin inverse of sin of 1 plus x square by 2 plus 2 secant inverse of secant x. Obviously, cos inverse x is there, so x belongs to 0 to 1, because the question is talking about only the positive root. The overall domain is minus 1 to 1, no doubt in that. So cos of cos inverse x, simply x. Sin inverse of sin of this quantity. If x belongs to 0 to 1, 1 plus x square by 2 also belong to the principal range of sin inverse x. So it is simply 1 plus x square by 2 is equal to 2 secant inverse of secant x. Again it is 2x, because x is lying in the interval 0 to 1. Okay. So we have x square minus 2x plus 1 equals to 0, which gives you x minus 1 whole square equals 0. The only positive root is x equals 1, and it is equal to a. A is the positive root. The greatest integer of the modulus value of 10a will simply be equal to 10. Okay, we have option number R as the only correct choice for D part. Okay, let us move on to question number 60 now. This question says that again match the statements in column 1 with column 2. A part says that the value of x at which f dash x vanishes for fx equal to 2 plus x plus integral from 1 to x ln squared t plus 2 ln t dt is a plus b into e raised to power minus 1, then a plus b is less than. So we have fx as x plus 2 plus integration of 1 to x ln squared t plus 2 ln t. Students, applying Newton-Leibniz formula and differentiating this particular function to find out the value of x where f dash x vanishes, we will have f dash x is equal to 1 plus differentiation of x is 1 into ln square x plus 2 ln x. So we have f dash x is equal to ln x plus 1 whole square. Obviously, if f dash x is 0, ln x is minus 1, x is 1 by e, which gives you a equals 0, b equals 1, a plus b is less than p, q, r, s. So a matches with p, q, r, s, because a plus b is 1, 1 is less than 4, 5, 6, 7. Okay, let us move on to the next part. B part says that if alpha plus 2 times integral 0 to 1 t square e raised to power minus t square dt is equal to integral 0 to 1 e raised to power minus t square dt, and alpha is equal to lambda plus mu times e raised to power minus 1, then mu minus lambda is less than. Students, how to simplify this particular integral? Over here, alpha plus 0 to 1, we will apply by parts here. We'll have e raised to power minus t square into minus 2t. T square was there, I have used minus 2t, 2 was also there, so I'll have to multiply it with minus t dt is equal to integral 0 to 1 e raised to the power minus t square dt. Fine. So what we'll do, students, we'll apply by parts in the left hand side. I'll have alpha plus first function as it is minus t into integration of second function. So e raised to power minus t square will be taken as p, minus 2t dt will be dp, it will be e raised to power p. So e raised to power minus t square from 0 to 1 minus differentiation of first function, that is minus 1. So plus integration 0 to 1 e raised to the power minus t square dt. That will cancel from the right hand side. So this is alpha plus, putting t equals 1, I'll have minus 1 into e raised to power minus 1 equals 0. So alpha is 1 upon e. So again, lambda is 0, mu is 1, mu minus lambda is 1, and it is less than p, q, r, s again. So B part also matches with p, q, r and s. Okay, let us move on to C part. C part says that if limit x tends to 0, 2 cos square x by 2 minus 1 whole raised to power x raised to power minus 2, that is 1 upon x square, is equal to p plus q into e raised to power minus 1 by 2, then p plus q by 2 is smaller than. Students, if I directly put x equals 0, the number is 2 minus 1, that is 1, and the power is infinity. So 1 power infinity format, e raised to power same limit into fx minus 1 into gx. So this is 2 cos square x by 2 minus 1 minus 1. So minus 2 into gx, 1 upon x square, which will give you e raised to power limit x tends to 0 minus 2 sine square x by 2 upon x square, which will give you again e raised to the power minus 1 by 2 directly, because sine square x by 2 upon x by 2 whole square will give you 1, and this will be the answer. So p is 0 clearly, q is 1, p plus q by 2 is half, and half is smaller than all the numbers on the column 2, p, q, r, s, t. Okay, all 5 are correct. Let us move on to the last part now. D part says that if limit x tends to pi by 2, cosecant x minus cos x whole raised to power tan x is equal to p plus e raised to power minus q by 5. D part says that if limit x tends to pi by 2, cosecant x minus cos x whole raised to power tan x is equal to p plus e raised to power minus q by 5. Then p plus q is less than. Students, cosecant pi by 2 is 1, cos pi by 2 is 0. So 1 minus 0 raised to power infinity. Again 1 power infinity format. Let us solve it by the standard format. E raised to the power limit x tends to pi by 2. Cosecant x minus cos x minus 1, that is fx multiplied by tan x. That will be e raised to the power limit x tends to pi by 2. It can be readjusted as cosecant x minus cos x minus 1 whole divided by cot x in order to create 0 by 0 form. So let us apply L'Hospital rule. So e raised to power limit x tends to pi by 2 minus cosecant x cot x is the answer for the differentiation of cosecant x, minus cos x is plus sin x divided by minus cosecant square x. Cosecant x as well as sin x is 1, cot x is 0. So this is e raised to the power 0 plus 1 upon minus 1. So e raised to power minus 1. So we have, students, p as 0, q as 5. So p plus q is 5 simply. It is less than 6 and 7. So D matches with R and S. Okay. So with this we come to the end of discussion of this particular paper. I hope you have learned a lot of new concepts in the discussion. Thank you very much. We'll see you again very soon.